Yeah, I can see course overview. What is data warehouse? Yeah.
Right. So fine. So in the beginning, we'll go for some concepts like what is data warehousing and the comparison of OLTP system with OLAP system, like OLTP versus the data warehouse,
Uh-huh.
and then the architecture of warehouse and
Uh-huh.
the components, all this stuff. So the definition of warehouse, all this stuff we'll see. So these kind of inputs definitely will be useful when you get into this environment.
Uh-huh. Okay.
So, and these presentations I'll share with you. I'll see that we'll get it through some mail
You will send it to me by.
through the organizers.
Oh, okay. Not a problem. Uh-huh.
Okay, according to you, what is data warehouse? Any basic definition?
What I understood is data warehouse is also a database which
Yeah,
stores
exactly.
all historical data for the purpose of analysis of by the business intelligence team to analyze their business.
Yeah.
So is it? I think that will solve that question. I think that will answer.
Yes, yes. Yes, yes, obviously. So the data warehouse is a database,
Mm-hmm.
okay, so which is designed for a particular purpose, okay.
Uh-huh.
There might be different databases for different purpose. So
Okay.
like a database might be planned for transaction processing or operational support.
Uh-huh.
Our database might be planned for some staging purpose. Our database might be planned for historical storage purpose, for archiving or backup.
Uh-huh.
So there might be different purposes for database. So mainly the warehouse, it's a type of database. It's a database, but mainly planned for query and analysis, okay,
Okay.
rather than the transaction processing.
Uh-huh.
So and it contains historical data. So obviously, whatever data you get into warehouse, from where you get, so from some transactional system, obviously.
Uh-huh.
Like today's present data becomes tomorrow's history.
Yes. True.
In a
Yes.
transactional system,
Uh-huh.
you said to be you have present data there. So today's present, in future you load it to the warehouse as a history. So periodically, how the warehouse gets the input or updates is obviously from transactional systems, OLTP systems.
Okay.
Okay,
Uh-huh.
and if you talk about a data warehouse environment,
Uh-huh.
so you need to always include the ETL process
Uh-huh.
when you talk about a warehouse. Because without ETL, it is not possible that you maintain or update a warehouse. No?
Uh-huh. Yeah.
So periodically, so if you want to get the input to the warehouse, the updates to the warehouse, or the data like loaded to the warehouse, we have the ETL process. So from transactional systems, we extract the data
Uh-huh.
and make necessary changes
Uh-huh.
and then load it to the target warehouse.
Okay.
So ETL is always dealt with.
Okay.
Like actually, ETL is a concept which is simply okay, uh, like even discussed in simple environments like where you would like to move the data from one location to the other.
Uh-huh.
For example, I have a simple task of moving
Uh-huh.
data from one location to the other, like one platform to the other. There also I can think of using some ETL
I
or
see.
ETL tool.
Uh-huh.
Like you pull the data from one platform, convert so that it fits into the other platform, okay,
Okay.
and then dump it there.
Uh-huh.
So for such kind of simple data movement tasks also I can use. But where ETL tools are regularly widely used is in data warehousing solutions implementation.
Okay. Okay.
Okay, so because here I require mainly, here you can utilize the expertise of ETL
Uh-huh.
because you are not just moving the data from one platform to the other,
Uh-huh.
but you require even more than that. Like you go for integration, you plan integration,
Uh-huh.
no? Because data is never available in one single platform or one single location.
Uh-huh.
You see that you pull all that information, whichever is available in maybe in different corners. Okay, your business might be okay, like might be operated in different geographical locations. Okay,
Uh-huh. Uh-huh.
and there might be different systems. Maybe have different corners of business, different areas of business. where the different methods are used for data storage or maybe information processing. Okay, I may be having different systems, okay, for handling the data, processing the data. So you might be having data in different systems and different formats, different platforms, different locations. You can have a diversified situation from where you need to get the data. So ETL tool should have an ability, obviously, to pull the data from any kind of a location or any kind of a platform, any kind of a system, no? And it should have the capability of integrating that, keeping all that together so that it can fit in if required. So make them into one form. Any conversions are required. Okay, any changes are required. These all capabilities. So we need to see. We need to have an ETL tool. So ETL tools are often discussed with like warehouse. They are associated with warehouses.
Okay. Okay.
So that's why warehouse environment, whenever you talk about, it includes this ETL process, extraction, transformation, and loading. And then it includes online analytical processing also. That means after you get the data loaded to the warehouse, what will you do? You go for query and analysis on it. So once you have the data of organization available in one single location and in one single format or form, so that data it is utilized for business intelligence purpose or for building analytical solutions. So people can plan data analysis on that, reporting solutions on that, and people can plan like data mining also, that is digging into facts. Analysis tells, okay, what happened. Okay, mining can tell how it happened, because of what factor it happened, like that. So digging into facts is like mining. So this is all is possible only only when you have the data available in one single location and one single form. So OLAP is for delivering information to the end users, mainly the business users who require crucial information, not only to run the business but also to like manage and like take some decisions or plan for the future. So this is crucial. So Informatica is taking care of ETL part. Okay. So OLAP is done by BI tools or reporting tools or tools we have. So in the total warehouse environment, you find two kind of solutions: ETL solution and OLAP solution. So together it makes up the total warehouse solution. So ETL said to be a backbone of BI, business intelligence. Because without ETL, it is not possible that I can plan effective BI solution.
Okay.
Solution. And this is all to make the enterprise understand more about itself, its products, its customers, and the market services and all. This is all to get the insights of your business, of an organization. Okay. So who needs insights of organization? Like who needs to know the top to bottom of organization? So obviously the main concentration is the managerial people, decision makers. These are the main end users. Okay. So who are benefited out of this.
All right.
So there is a definition for data warehouse. I think you might have come across with this definition. Did you? It's a famous definition. This is given by a person who is considered to be the father of the warehouse.
I see.
William Inman. So according to him, data warehouse is a subject-oriented, integrated, non-volatile, and time-variant collection of data in support of management decisions. It's a worldly accepted definition for
Mhm.
data warehouse.
Okay.
So to understand warehouse or warehouse data storage methodology or data storage structures and all,
Mm-hmm.
so definitely you need to understand each keyword in the definition.
Okay.
Like what do you mean by subject oriented?
Mm-hmm.
What do you mean by integrated database? Or what do you mean by non-volatile database? What do you mean by time variant collection of data? Okay, so each thing you need to have an understanding
Mm-hmm.
to understand the definition, what exactly it is.
Okay.
So subject oriented.
Mm-hmm.
So have you heard of this before? This definition?
Ah, yes. I went through online, like, so I need little explanation about.
Okay. So you got the definition but not the explanation of it, no?
Ah, yes, yes. I read that definition online before once.
Okay. Okay. Yeah, it's a universally accepted
Yeah, yeah.
definition for
Hmm.
warehouse.
There are two people, Iman and Kimball or something. I read it in.
Yeah, there are two people, key people, main people
Uh-huh.
who influence the warehouse architecture.
Right.
So there are two methods of implementation in warehouse.
Mm-hmm.
Okay, one is Inman method, like Inman model user.
Mm-hmm.
Another is Kimball model.
Right.
We'll come to that
Sure,
later.
sure, sure. Mm-hmm.
So after some basic.
Mm-hmm.
So subject oriented. Okay. So what do you mean by subject oriented? So that is this talks about the data organization in warehouse. Okay.
Mm-hmm.
So the data in the warehouse is organized around the major subjects of your enterprise, which can be called as high level entities. Like when you have a comparison of this with the normal transactional system,
Mm-hmm.
how data storage is planned in transactional systems, it is not subject oriented there. Okay,
Mm-hmm. Yeah.
how data organization is planned in transactional systems,
Mm-hmm.
how people plan storage.
Mm-hmm.
Actually, the method of storage is different in transactional systems,
Mm-hmm.
or the model of storage is different. If data model is different,
Okay.
which is planned for the storage in transactional or operational
Mm-hmm.
systems. Okay, so there they go for a different model, which is called as a relational model or entity relational model. Okay,
Mm-hmm.
so like there we don't talk about high level entries, but we'll be talking about low level entries there.
Mm-hmm.
Like we'll be trying to organize the data or store the data according to the entities that we have
Mm-hmm.
in the business process involved. Okay, like if you take the tables, okay, of the database, how the tables are planned is according to the entities which got involved, according to the business process that is going on. To keep the information, so the tables will be formed, the
Okay.
tables will be planned. Okay.
Mm-hmm.
So when you opt a database in ER model or entity relational model,
Mm-hmm.
there is some procedure to do.
Mm-hmm.
Okay. So, but when warehouse is planned, it is planned very much differently. The model of warehouse is a very different model. It is called as a dimensional model.
Mm-hmm.
The warehouse design,
Right.
the construct is based on a different model,
Mm-hmm.
dimensional model. So we'll discuss what
Okay.
exactly it means by dimensional model and how it can make a difference.
Okay.
Okay, so in warehouse database, the data organization is based on subjects, major subjects.
Mm-hmm. I see.
So, for example, so in your organization, you might have different corners of your business. Okay,
Mm-hmm.
you might be having financial sector,
Mm-hmm.
you might be having sales, like you might be having manufacturing. Okay, you might be having HR department, accounting department. There might be different corners of your business. There might be different departments in your business. Okay,
Mm-hmm.
so maybe you have a different system for every domain of your business or for every maybe corner of your business,
Mm-hmm.
expertise of your business.
Mm-hmm.
Maybe for sales, it might be a separate application.
Mm-hmm.
What I have built. For finance, it can be a separate application. For manufacturing, it can be a separate system I have. How do I manage the data or maintain the information?
Mm-hmm.
There might be different things, how the data is organized, stored. Okay. But when I try to plan a warehouse, okay, I try to organize the data in warehouse subject wise.
Uh-huh.
Okay, that means the major entities or major subjects in organization are like mainly the the nouns that you can like identify in your business or business environment. Like if you take, okay, what is, for example, if you take a small sales kind of environment, okay,
Uh-huh.
maybe my business is into selling of products to customers. Okay. Maybe I get the product from some suppliers. I may not manufacture the products.
Uh-huh.
Maybe I'll be getting from suppliers and I'll be selling them to customers. I'm a reseller.
Uh-huh.
Okay. So in that, what is happening? I'm I'm ordering the products from like I'm getting the products from suppliers and I'm selling the products to customers. So in this business scenario, business environment, we have major subjects like customer, supplier, and product. Okay.
Yes.
But this information might be available in different corners of the business.
Uh-huh.
Okay. Like sales information might be separately kept in some separate system. Okay. Supplies information can be separately kept in separate. Inventory management can be made separately. Okay.
Uh-huh.
So at operational level, I may have information in different areas of my business maintained in different systems.
Uh-huh.
But when I try to plan a warehouse,
Uh-huh.
I try to gather the information and group up the information or categorize the information or organize the information subject wise. It might come from a particular operational system or it might come from different systems.
Uh-huh.
But you take that subject data to one place
Uh-huh.
in warehouse.
Uh-huh.
Subject wise you organize like customer data in one place. That might come from different systems of your organization, different corners of your organization. Might not be from one. Like supplier data wherever you have, so that you collect and keep under one subject,
Uh-huh.
product data. So the organization of data is different here.
Uh-huh.
Okay, when you compare with the operational systems, it is very much different. Okay,
Uh-huh.
so mainly the operational systems are designed around the applications and functions. Okay, like for example, how the applications are, how the operational systems are planned, like based on the function. For example, if you take some banking kind of an environment,
Uh-huh.
loans, saving, credit cards, these are the main functionalities we have. No?
Uh-huh.
So applications are planned accordingly. For loans, maybe some applications separately I have. For savings, maybe separate section, separate application, separate system. For credit cards, it is separate.
Uh-huh.
Okay.
Uh-huh.
Let it be like this, different according to my functionality.
Uh-huh.
Okay. But when it comes to the warehouse, we have to aggregate, like gather the data from all these systems and organize subject wise.
Uh-huh.
Let it be from any system.
Uh-huh.
So subject-oriented data organization we find in warehouse, which is not practiced at uh, like at operational level or at transactional level. Okay. And another aspect of warehouse is time variant. What can be time variant
I'm very
in warehouse?
yeah, okay.
Hmm. Yeah. Yeah. Tell me.
Yeah, I think it's a particular period or they choose a year wise or a particular year or something like that. That's what I was thinking about it. Yeah.
So in warehouse, what you try to have is historical stories. Okay.
Yeah.
Okay. So for example, I'm trying to have sales history in my warehouse. Okay.
Uh-huh.
So I'll be having the sales information over a period of time.
Okay.
How I'm getting sales, like every day. For example, if I'm trying to keep the information at a day level, every day sale I'm trying to maintain in the warehouse. You find a lot of repetition of data in warehouse normally.
Uh-huh.
Like actually, if you talk about one major feature of your transactional system, transactional database.
Uh-huh.
In transactional databases, we talk about normalized data.
Uh-huh.
What do you mean by normalized data?
All the tables will be divided into the entities will be separate with the relationship.
Yeah.
Uh, is it correct or
Normalization talks about less redundancy, elimination of redundancy. Okay. So transactional database data you find highly normalized. Highly normalized is nothing but less redundant. less redundancy is nothing but less repetitive data you find.
What is
Data
redundancy?
repetition,
Redundancy means like what exactly that mean? Redundancy
redundancy means repetition, data repetition.
or data
Okay,
repetition? Okay. Uh-huh.
yeah, unnecessary repetition of data. That is like same data if you are trying to store in
Uh,
different places again and again in different tables or
uh-huh.
in the same table. Unnecessarily, if you are trying to if you are repeating that storage,
Uh-huh.
unnecessarily it will occupy the disk space. No?
Uh-huh. Yeah.
Repetition was a problem earlier actually.
Uh-huh.
See, in relational databases,
Uh-huh.
data repetition was like minimized.
Uh-huh.
Okay,
Uh-huh.
it was eliminated mostly.
Right.
Why it has been done is because before you could have relational method of storage,
Uh-huh.
people were using other methods of storage. Okay, in earlier methods, old methods,
Uh-huh.
they used to have a lot of problem with data redundancy. That's why they have worked on it and they have minimized or eliminated
Uh-huh.
that redundancy of data.
Uh-huh.
Okay, so transactional data is highly normalized data, like less redundancy you find, almost no redundancy you can say,
Uh-huh.
but minimum redundancy will be there.
Uh-huh.
Okay, but when you try to compare the same with warehouse, in warehouse redundancy will be high. Okay, because what happens is same information you keep over a period of time. No? How it
Uh-huh.
is getting changed. For example, if you talk about this time variant, so
Uh-huh.
it is storing of data
Uh-huh.
as a series of snapshots or views, which records how it is collected across time. Like information you are trying to collect across time and you are trying to keep it.
Uh-huh.
There you find a lot of repetition. Like same customer might come 10 times, no? Every day.
I see. Yeah. Yeah.
If
Yeah.
I'm trying to keep 1 year of data in warehouse, 1 year history, same customer might come say, 10, 20 times
So
in a month or
repetition,
in a year.
repetition means it's a so we can't say that duplication, right? So repetition will be with a different
Yeah,
information.
yeah.
Uh-huh. Okay.
Mm. It can be at with a different time zone, like time frames, no?
Okay. Okay.
With like the same customer data might repeat maybe with a different products or maybe with a different dates or days, no? Months, years. So,
Right.
but in the same day also a customer might purchase
Yes.
different products,
Yeah.
no?
Yeah. Same customer
Possible.
might have purchased twice. Yeah.
Yeah. So data will repeat, but with a different aspect might be. But
Okay.
we cannot avoid this kind of a repetition. No?
Uh-huh.
In warehouse, we cannot avoid data repetition because it is required here. Because we are trying to have data collection over a period of time, across time.
I see. Okay.
Obviously, repetition is it occurs and it is required actually.
Uh-huh.
So, so there is a on purpose in transactional system data repetition is like minimized or eliminated,
Uh-huh.
but on purpose it is allowed in warehouse. It is
Ah,
required in warehouse.
okay. Okay. But
So
in the data warehouse, there cannot be a duplication, right? It will not any duplication of the records will be there, right? It will be there.
yeah, duplication can be avoided,
Okay.
obviously.
Uh,
Like yeah, duplication is like normally if you take any table, okay, in a database,
uh-huh.
so duplication is actually avoided because in databases there is a practice like going for a primary key in a table. No?
Yeah. Yeah.
So when you implement a primary key in a table, obviously duplicate records it won't allow.
Yes.
No?
Yeah.
So data repetition is different, duplication is
Duplication
different.
is different. Yes, I understand.
So having storage of data across time, collection of data across time,
Uh-huh.
it can help the business in doing the trend analysis. How your business behave behave like during the period. Okay, the patterns and trends of your business you can make out.
Uh,
Okay,
uh,
so the behavior of your business you can make out.
uh-huh.
This is very useful for the decision makers actually, the
Uh,
people who are into decision making and business planning.
uh,
Okay, so in warehouse it is important that so we have to make like capture the change over time. That is, we collect information across time. So that is an important aspect of warehouse, time variant aspect. And another keyword we have in the definition, that is warehouse database is an integrated database. What do you mean by integration? Integrated?
Integration is together, putting
Yeah, putting it
yeah,
together.
yeah, yeah.
So warehouse data is integrated.
Mhm.
So in warehouse, data is stored in a single location. So this data might come from different geographical locations, or it might come from different systems. No?
Mhm.
It might be from different platforms or forms.
Mhm.
You keep it all together in one location and in one form. You have to have this integration of data.
Mhm.
It can be coming from different systems. Okay?
Yeah.
It can be coming from different applications of your business.
Mhm.
In all these systems, in all these applications, you might have customer data. No?
Yeah.
All these you can integrate together and have it in target, kept together. Okay.
Mhm.
So integration is, it's said to be closely related with subject orientation.
Mhm.
Okay. So in subject orientation also, we have discussed similar thing.
Yeah. Yes.
So even though you have information in different systems, we are trying to put it together under one subject, all the relevant data,
Mhm.
subject information.
Mhm.
That one subject. Here also indirectly we are doing the integration.
Mhm. Mhm.
So from different sources, the data you are trying to keep it into one location and one format. This is integration. And obviously you can even resolve the problems such as naming conflicts and
Mhm.
inconsistencies. That is taken care anyhow when you are trying to integrate. Just a second. Yeah, can you hear me?
Yeah. Yeah. I can hear you now.
Sorry, I got a sore throat actually.
Yeah. It's
If I
okay.
talk
Don't
much,
worry.
I'm getting cough.
Yeah. We can,
so,
don't worry about it. I'll be always with you. Don't worry.
so the next aspect is non-volatile.
Mhm.
Okay, so uh, transactional database is said to be like volatile database. Volatile means
Updatable.
mm, updatable, and often the data of the database changes, no?
I see.
Because of the updates,
Yeah.
because of the new data comes in or modifications.
Mhm.
But warehouse data is said to be non-volatile. Non-volatile means it is not updatable. Almost it is like read-only data.
Mhm. Mhm.
So because it is history, we are not supposed to update it.
Mhm.
No? If you update, what happens? You will lose the history.
Oh
So
yeah.
what is the like importance of warehouse? We are trying to have historical
Historical
storage of data
data.
so that we can have an analysis over a period of time.
Mhm.
Okay. If you are trying to modify that, overwrite that, you will lose the past information. That is history you lose. That's why we don't overwrite the data or update the data. Okay. If you
So
are
that
trying to
means
capture,
okay.
yeah,
No, that means if any updates comes, it will be added as a second data of that old
Yeah.
data, right?
So
That
if any updates comes, so
uh-huh.
you need to take care that it maintains all the updates, like total history in the target.
I see.
So you need to maintain every update, every change of data. You need to have all, not just one of it.
Mm.
So you need to additionally maintain information with every difference. Okay? So that you take care. Like that is there is a concept in warehouse
Mm-hmm.
uh, by name SCD concept, slowly changing dimension.
What is the name?
SCD, slowly changing dimension.
Oh, okay, okay. Slowly.
So, so there we have a concept like how this is taken care.
Uh-huh.
Like when you have some updation coming from source,
Uh-huh.
like in source some information got updated
Uh-huh.
and already this information is there in target, but this updation, how do you get to the target? How do you maintain to the target?
Uh-huh.
Okay. So without losing history, you need to maintain. No?
Oh, yeah,
So
exactly. But this happens very often in the data warehousing, or very rarely happens. This kind of
it happens like not you cannot say very rarely because it happens in many occasions.
I see.
So now we cannot say rare actually.
Mm-hmm. In the daily practice, this happens most of the time.
Yeah, yeah,
Okay.
it happens.
Mm-hmm. Sure.
Maybe even though if it is occasional, but the concept is
Mm-hmm.
not occasional.
Mm-hmm.
It happens. Like
Mm-hmm.
maybe see how rapid the changes are done actually. It
Uh-huh.
depends. Okay. So maybe sometimes changes can be occasional.
Mm-hmm.
If changes are occasional, you need to take care of it occasionally.
Mm-hmm.
But even though it is occasional or rapid or like regular,
Mm-hmm.
the logic building you need to take care of it. No?
Yeah, exactly. Yeah.
Yeah,
Mm-hmm.
that's why let the frequency be any frequency,
Okay. Okay.
occasional or maybe regular.
Mm-hmm.
But in logic building, we have to take care.
Yes.
If in this kind of a situation, how you'd like to take care of data load to the target,
Yeah.
how you'd like to maintain the data
Mm-hmm.
without losing history because of maintaining the updates.
Mm-hmm.
Okay, what is the method? So there are actually three possible methods, one of which is best actually. So that is taken care, like so that you can maintain all the history in the target.
Mm-hmm.
So we'll discuss that SCD concept shortly.
Okay.
So transactional data is volatile data we say, and
Mm-hmm.
warehouse data we say non-volatile. So the difference in between OLTP and data warehouse. This also you can have knowledge in.
Mm-hmm.
You know what is OLTP? No?
No,
Transactional
no,
system.
no, no. But there are only little confusion. OLTP, OLAP. So can you please explain to me in a normal way, so I can be it will be more comfortable for me that way.
Okay, shortly let me explain.
Mm-hmm.
So we were talking about data warehouse. No?
Yeah.
So here we are trying to have the history of the data. So from where we get this information? Here we are trying to have historical storage of data. No?
Yes.
From where will you get this information?
That means in the operational data source.
Operational source.
Mm-hmm.
You have operational. In operational source, what you have, see this operational database is actually is a backend of your business operations. Okay.
Yes, yes, yeah.
So business operations are performed by maybe the employees. Employees will be having some business application in front of them, you know, some kind of a software system they have in front of them to perform their daily activities, business operations. Okay. So every business operation, what you can call it as a transaction of business. Business operations are business transactions. Okay. So what you are keeping a track is the daily transactions of your business to the database. Okay. That's why operational is one word that we use. The other word is transactional. Okay.
Transactional.
The database can be called as transactional. So this process is called as online transaction processing, OLTP. So whenever you work with a transactional system in a like whenever you work with in this kind of an environment with a transactional database, okay, using a transactional system, taking up your tracking your daily transactions in detail, the backend database. So this process is called as OLTP process, online transaction processing.
Why they use online
So
OL meant for online? Why they say online along with the process transaction processing?
online means you'll be working on
Oh, okay.
like how people are working here. So they'll be working active, no, online.
Okay, okay.
See, whatever data you have in the databases, we call it as real-time data.
Oh, yeah, real time. Okay.
So whatever happens in your organization, it will immediately it gets reflected to the database. Immediately it will be tracked to the database. That is online. Okay, like so from such kind of systems, okay, you will be having your source data extracted, transferred, and loaded to the data process. Okay. So what you do with the data warehouse? You need to go for business intelligence. Okay. So who is the end user? The managerial person or the decision maker.
Makers.
Okay. So this guy will be having what kind of application in front of him? A business intelligence application. A business intelligence application can help him to navigate through the data and get the insights of the business. No?
Yeah, yeah.
So for an application, business intelligence application. Okay. So here the major activity I go for decision making or business planning. Okay. So this process is called as a OLAP process. Okay.
Okay.
Online analytical processing.
Okay.
Because the data whatever we have in warehouse, we always retrieve, like we go queries, business queries. And that query data we use it for analysis, decision making, business planning. So this is called as online analytical processing.
I see.
When you work with warehouse. That's why I said there are two parts we have for warehouse. No?
Yeah.
ETL and OLAP. Two parts. So together it makes up the total warehouse solution. Okay. So ETL is the backbone for BI, business intelligence. Like it. So we have some concepts anyhow to discuss. So after the concept, anyhow we'll be going for the tool and all. Okay. The Informatica architecture we'll discuss. Components we'll discuss. Okay. And tool installation I'll show you in your machine. Okay. So meanwhile you'll get the links given to you so that you can download the necessary things and keep it ready so that I can help you out in installation of it to set the product in your system so that we can have your practice locally.
Akul, this OLTP, OLAP, if you know this much knowledge is enough, or we need to. There is a lot of big articles regarding that. I seen, I confused us. That's why I'm just asking. If only this much logic is enough for knowing, right?
Yeah. Or else tomorrow I'll give you some briefing on it. Okay. The comparison of OLTP versus OLAP. Okay.
Okay.
The main points we'll discuss. Then accordingly you can identify. Okay. Whether it is sufficient.
Okay, not a problem.
If you have anything in mind, like if you have any
Questions?
particular question or maybe
Mm-hmm.
If you are trying to have a particular clarification,
Mm-hmm.
that also we can. Yeah,
Yeah, sure, sure. I will note down all the questions. Then we will finally, when you are in the times, then we will discuss about it.
yeah, yeah, sure.
Mm.
Okay, then tomorrow I'll catch you on in time 10 p.m. Okay,
So today's
uh,
class is
we'll have. Yeah, today class will wind up here because I have another session after this.
uh-huh.
So 1 hour we have planned for our session. Okay,
Yeah,
if
yeah.
you can like make it half an hour early, something like that, we can
Uh-huh.
have 1.5, something like that. Okay,
So that means
so
we can
that
start
we'll
around
discuss in the future.
yeah, yeah. So if we start around 12 o'clock,
Mm.
that means we can have 1.5 hours.
Yeah, yeah, like that. Okay, anyhow, so for a couple of days, let us do 1 hour, and by weekend, if we make out, now, if you decide,
Uh,
we can make it 1.5 hour like that. Okay,
okay, not a problem.
if you give your possibility and you check out your availability, accordingly, we'll switch it
Okay.
1.5 hour.
What will be tomorrow's class? What do you think? What topic we can discuss?
Yeah, tomorrow we'll compare the OLTP, OLAP.
Mm-hmm.
Okay, and if you have any questions on that, we'll handle it,
Mm-hmm.
and then we'll proceed. Okay.
Proceed with ETL, like Informatica.
Yeah. So
Okay.
if you are comfortable with OLTP, OLAP comparison,
Mm-hmm.
and if you are comfortable with other concepts like what is a warehouse, what is a data mart, what is an operational data store, like that. So
Mm-hmm.
few other terminologies, if you are aware of that,
Mm-hmm.
so we can proceed with dimensional modeling discussion.
Mm-hmm.
Okay. How the data of warehouse is organized and
Mm-hmm.
what is the data model involved
Mm-hmm.
to plan a warehouse. So those topics we have to discuss, dimensional modeling topics.
Oh,
After that, we can jump into the tool ETL part.
okay. Okay. In the
Maybe one
meantime,
or two classes we'll plan
yeah.
for concepts, and then we'll jump into that.
Mm.
Anyhow, I'll give you the the material, the presentations, okay, so that you also can go through.
So can you send it today now? The PPT file.
Yeah, I'll send it today. Yeah.
Sure, sure.
Okay.
Okay. Okay. Thank you very much. See you
Okay. Thank
tomorrow
you. Yeah. See
by
you.
this time. Okay. Bye.
Yeah. Yeah.